Namaste everyone, it's me Ranjan Dhakal, your science teacher. In the previous classes we studied about acceleration and retardation, some of the terms that are used in motions. Now today we are going to continue the lesson with equations of motion. There are three equations of motion and that can be summarized as the first one v equals to u plus at, second one s equals to ut plus half at square, third one v square equals to u square plus 2as. Here the symbol v, u, a and t, they have the usual meaning. That means v final velocity, u initial velocity, a acceleration, t time taken and s distance traveled. Now first we are going to the proof of v equals to u plus at, that is the proof of first equations of motion. Now if a body is traveling with the initial velocity u and after some time, that means after time t second, its velocity becomes v, then we all have studied the definitions of acceleration. That is, mathematically acceleration is change in velocity divided by time interval divided by time taken. Now change in velocity means previously it was initial velocity and after some time it reaches final velocity. That means the change will be final velocity minus initial velocity. V minus u divided by time taken is t. If we cross multiply this, a multiply t will be equals to v minus u. On arranging this, we get v equals to u plus at, which is the first equations of motion. Let me repeat again, v equals to u plus at, first equations of motion. Now moving to the second equations of motion, that is s equals to ut plus 1 by 2 at square. Now a body is traveling with an initial velocity u. After some time t, it reaches its final velocity v, and on this period from u to v, the body travels a distance of s meter. That means we all have studied average velocity is equals to v plus u divided by 2. Why v plus u divided by 2? Because average means the mean. That means there are two velocity. The first one is initial velocity and the second one is final velocity. Its average will be its sum divided by 2 because there are two velocities. Now also in the previous chapter, previous lesson, we have studied the definitions of distance mathematically, which will be given by average velocity multiplied time taken. Average velocity here is v plus u divided by 2 time taken t. Now here in first equation we have already concluded to v equals to u plus at. That means instead of v we can write u plus at. This gives u plus u equals to 2u plus at divided by 2 times t. If we multiply the t with the numerator, it will be 2ut plus at square. Now when we open it into v shape, opening in v shape means just the opposite of LCM. 2ut divided by 2 plus at square divided by 2. In the first one, the 2 and 2 they cancel each other, gives ut, and here half at square. That means we can get our second equation of motion, that is ut plus half at square. Now on moving to the third equations of motion, that is v square equals to u square plus 2as. Same, the body is moving with an initial velocity v. After some time t, it reaches to the final velocity v, and in this period it travels a distance of s. Now we already have studied distance travel equal to average velocity into time taken. The average velocity we have determined it in while proving the second equation, average velocity equals to v plus u by 2. That means average velocity v plus u by 2 into t. Also now while proving this third equation, there is no time taken. That means we have to remove this t. For this we are going to take the relation of acceleration. That means acceleration is the rate of change of velocity. Now if we cross multiply this, we will get t equals to v minus u by a. Now we are going to substitute this value of t here. Now after this we get s equals to v plus u by 2 into t. T means v minus u by a. Now let's multiply these two terms. The numerator is in the form of a plus b and a minus b. That means their multiplication will give a square minus b square. That is v square minus u square over here. Now denominator 2 multiply a gives 2a. On cross multiplying we get 2as equals to v square minus u square. Let's arrange this. We will get the proof of third equations of motion, that is v square equals to u square plus 2as. Now we, after proving this, we use all these three equations of motion on solving the numerical problems related to the moving objects, moving bodies. Now for that we have to keep in mind some of the things, that is a body, if it comes to rest, moving body comes to rest, then the final velocity will be 0, because at the initial phase it's moving, that means it had some velocity, but after some time it comes to rest. Rest means no movement, that is v becomes 0. Now if a body at rest starts moving, or if a body starts from rest, that means at the initial phase it is rest, that means at the initial phase it is not in motion, that means initial velocity will become equals to 0. And in the third case, if a body moves with a uniform velocity, that means the initial velocity and final velocity becomes equal. At that case, acceleration due to gravity will be equal to 0. And for a freely falling body, acceleration due to gravity will be acceleration of that body will be equal to acceleration due to gravity, that is 9.8 meter per second. That this is because a freely falling body falls towards the center of a planet, here in case center of the earth, due to the acceleration due to gravity of earth. That's why they become equal. Let's recap again. There are three equations of motion. The first one can be concluded at v equals to u plus at. Second one is s equals to ut plus half at square, and the third one is v square equals to u square plus 2as. This is the proof of all these three equations of motion, and some important notes while solving the numericals. Next class we will come up with solving numerical problems related to these motion, equations of motions. Till then, stay safe, practice, take care yourself, help family. Thank you.